Hey guys, it's Galactic Lum, and welcome to another episode of the C# 2D Game Engine series. So in this episode, we're going to be doing the second part of the Sprite, portion, and today we're going to be loading in our Sprite. And I guess, somewhat doing some more OpenGL stuff, because we're going to have to create our texture buffer. So, let's get started, and we're going to finish off the OpenGL stuff with creating a new texture class. So, just create a class called texture. Now, you could call this texture 2D, because technically they're all 3D textures as well, but those are typically referred to as cube maps. At least that's what we're going to be implementing later on. And those are not going to be important right now, so I'm just going to call this texture. Right, I'm just going to get rid of these. Actually, I'll leave them in, although I'm not sure if it's going to be needed at all. I think we're only going to need OpenGL. So, what is this going to have? Well, our texture is going to have a few things. The first thing it's going to have is a public read-only int ID, and this is going to be our texture buffer. So you could call this buffer or something, or buffer object or texture object. I'm just going to call it ID. So this is the texture ID. The next thing we're going to have is a private static. So since it's static, it's going to go before our public members. So private static texture2d. Oh wait, no, texture. And in my reference, they call it a texture 2D. But here I'm going to call it texture. And then we're going to name this last texture bound. So what does this mean? Well, this is the last texture we bound. And this is so we don't have to keep binding the same texture over and over, especially if you're calling it every frame, and you only have one texture. It's kind of inefficient if it's already bound. So let's create a constructor. And since it's a read-only parameter, or since we have a read-only parameter, we need to take it in, because we can only set it when we're constructing the object. And that's good, because we don't want to modify this afterwards. That's the whole point of this. You do not want to modify it. Okay? So that's important, we keep that in mind. So, the next thing we want to do is we want to have a public void bind. And we want to have a uint unit. So this is the unit is essentially the slot we want to bind the texture to, and this is very important because the OpenGL supports up to 31. So we have to say if, first of all, if last texture bound is equal to this, get out of here, we're going to bail, we don't need to bind. At that point, we're going to say if unit is greater than 31, get out of here, because this is an out of range. So then after that, we're going to say gl dot, oh my god. There you go. GL and OpenTK graphics.OpenGL. There you go. Dot active texture. And then we're gonna say texture unit, the texture one plus, we're gonna have to convert this, cast this to a byte. Remember, enums are essentially just numbers. That's what they are. So we can do this. You can do arithmetic operations with enums. Keep that in mind. So yeah, we set the active texture to whatever unit, or the active texture unit to whatever unit we set. And then we're gonna say gl.bind texture, and then in here we're going to actually say texture target dot texture 2d, if I can find it. There it goes. And we're going to pass in the ID, obviously. And then we're going to say last texture bound is equal to this. So this is it. The last thing we have to do is make a deconstructor, and that's really simple. It should just be texture. That's our deconstructor. So this is called whenever. I guess we could make it public. Can you do that? No, can you make it private, since it is technically? Nope, doesn't have any. Okay, so I guess whatever. But a deconstructor is essentially, this is going to be called when the texture object is deleted. And this is important because we want to be able to free our texture. So gl.delete, or, sorry, I'm thinking C++. gl.delete texture, and we pass it in texture ID. And in fact, let's just go into our mesh 2D and do the same thing, because that was something we weren't doing. So let's create a big constructor for this, and let's say gl.delete buffer. So you see how we're generating a buffer? Now we want to delete it. We're going to delete our VBO ID. Then we're also going to delete our IBO ID. The last thing we want to do is just go into let's shader. Because that stuff, we have some program ID that I don't think we're deleting anywhere. It doesn't look like we're deleting it anywhere, so it's wise if we delete it here. So we're gonna say gl.delete program ID. There you go. So when it stopped being used, we're good to go. So now we have our texture. Let's create a new class called Sprite. Okay, this is actually what we're gonna use. So it's gonna be kind of high level. The texture is just the OpenGL implementation of it. And for this, there's gonna be some things we're gonna need to do. Well, we're going to need to have our width, right? That's something we want. In fact, I'm just gonna make it a getter, and we're also gonna need our height. That's something we also just want. But the other thing we're gonna need is we're gonna need to have our texture. So let's just do that. So public texture. Whoa, that scared me again. These screenshots always scare me. Texture get. So should we even get it? Or should it just be private? I mean, we don't want to. No, or yeah, let's make it private. I mean, private texture. That should be good enough. So then we're gonna have public sprite. We're just gonna take in a. Actually, we're not gonna have a constructor for this, and you'll see why in a minute. So yeah, I mean, we will have a constructor for it, but it's gonna be slightly different. So the problem we have right now is what we essentially want to do is load in our textures like this. So we have some sort of I don't know, like some class called resource, and then we can do resource.load, kind of like Unity, Sprite, and then we take it, and then this is the file path, or guess what, path to file, .png or something, just to make it more like a sprite. But the problem is, how do we know Sprite is a resource? Well, to do that, we can use an interface, and an interface essentially says, to be considered a resource, or whatever your interface is going to be, you need to implement these methods. So that's what we're going to do. We're going to make a new class. It's not going to be a class. It's going to be I resource. Now, the reason I put I in front of you, because it's a C# convention to put to append I in front of resources. It's kind of just a prefix. And in I resource, we're just going to specify you're going to need a load function, or you're going to need a load function that takes in a string file path. Okay. Now, another thing we can consider doing is making it so an interface is a generic. So now, if we make a generic here, and by the way, you'll learn about generics in a little bit when we implement that in our resource loading code. But yeah, so now we can say, hey, when you load, you're just going to return this. And that's what we're going to do. And the out makes a contravariant. Just so you'll see the resharper actually suggests that I do that. But yeah, it makes it contravariant, I think. Let me see. The resharper will tell me. Yeah. Oh, covariant. Okay. And basically, what this is, what a generic is it lets you specify any type for essentially this. And we can also add a constraint, I think, for new. No, you cannot. I was pretty certain you could, but guess whatever. But yeah, this just says I could take in any type, and any type can be a resource. But now what will happen is I say I resource of Sprite. So I inherit, but now it's gonna complain. See, interface member Sprite glum engine 2D I resource out Sprite .load string is not implemented. So let's implement the missing member, and boom. So at this point, we're going to implement this. Let's do that. Okay, so the first thing we want to do is create our texture ID. Or texture buffer. And this is going to be gl.genTextures. Oh my. Int texture ID is equal to gl. Oh my. Multiple choices. We want OpenGL 4. Dot create texture, or it's not create texture, my bad, it's gen texture. So there we go. So now we've created our texture buffer. Then we're gonna say gl.bind texture. We're gonna bind the texture we just created, so texture 2D obviously, to the texture ID we just created. And this way we can actually start setting it. So first thing we want to do, let's just set up a few parameters. So it's text parameter, or short for texture parameter. We need to pass in the texture target, which is obviously going to be texture 2D. And then we need to say texture parameter name, and for this one it's going to be texture min filter. Well, what this is this essentially is going to act like some sort of anti-aliasing, if you will. And I just use it in all my projects just because these parameters are going to just make your images look a little nicer, especially when you have a really large resolution image and the thing you're trying to display is smaller. So this stuff is just going to act as a sort of pseudo anti-aliasing. It's not going to be the best, but it will help. Although you may want to implement it further as a shader post-process. So the next texture parameter we're going to make is texture parameter name mag filter. So mag filter. And again, we have to cast it to a float and say texture mag filter dot linear. So boom. Then we're going to say, so this is where things start getting more stringy. So now we're actually going to have to do some string operations. So let's make it a string array called GL extensions. Well, what this is, and what we're going to be getting from this, is all the extensions of the texture. Okay, so gl.get string name dot extensions. So yeah, right there. And we want to split it by the spaces. Well, what now we're going to do is we're going to say if gl extensions dot contains, and then we're going to say gl extension, so ext texture filter, and then we want to see if our texture contains an anisotropic filter. Well, we need to do some stuff. Well, this is an older kind of filter. So what we need to do for this is we need to grab, first of all, we need to grab the filter amount from an older GL version of the library. So we want to say GL get integer, get pname. Okay, so we want to cast it. And then we're going to say old GL, but we don't have this yet, and I'll show you guys how you get this. Extension texture filter anisotropic dot max, I think texture, texture max anisotropy extension, I think that's what it is. And to get old GL imported, you have to do using old GL is equal to OpenTK dot graphics dot graphics dot OpenGL. Okay, so it was not anisotropy, it was max texture and okay, so there it is. So now we've got the filter amount. We need to say gl dot texture parameter texture target dot texture 2D, and the texture parameter name, not clamped to board though, old gl dot get I think it was extension texture filter something. Yeah, that was the texture max anisotropy, and then the filter amount. Okay, there it is. So that's if it contains the GL extension. If it does not, then we're just going to continue. Okay. So at this point, essentially what this is saying, if you guys are wondering, if we have an OpenGL extension with anisotropic filtering, which we probably don't, I don't think it's loading in. But now we have to create a bitmap, and to do this, you're going to be including system.drawing.imaging. I think. No, it's system.drawing. Imaging is when we get the bitmap data. And we're just going to pass in the file path at this point. So now, bitmap data, and you'll see how I'll include system.drawing.imaging. Bitmap data is equal to new bitmap. Oh wait, no, it's equal to bitmap.lockbits, and then we want to say new rectangle 0 0 bitmap.width, bitmap.height, image lock mode dot read only, because we don't want to write to this accidentally or on purpose. It's just better if we tell the application that we don't want to do anything with writing. It also saves memory. So then gl.text image 2D. Then we want to set the texture target. Although I mean, if you're saying it's a texture image 2D, why do you need to set the texture target? I feel like it's stupid. And then pixel internal format dot RGBA. That should be it. Whatever, I'll just... Oh no. Whoa. Control Z.RGBA, there you go. And then we want to do bitmap.width, bitmap. I guess you could get it from the height, for the data as well, but I'm not going to. Then bitmap data dot... You know what, actually let's get it from the bitmap data. It's gonna be just fine. 0, and then what we want to do is we want to set a pixel format. Well, this is actually using the wrong pixel format. For some reason it includes this, but we don't want to do that. We want to instead do pixel format with OpenGL, and that's going to be BGRA, and then pixel type dot unsigned byte, and then bitmap dot scan 0 or data dot scan 0. Yes, that's why we get the data. So you see now it's getting mad. So here we need to say system dot image drawing dot imaging. There you go. It's not mad anymore. So now we want to just unlock the bits. Which makes this bitmap data unusable at this point, which is fine. And then we're gonna say width is equal to bitmap dot width, height is equal to bitmap dot height, and then texture is equal to new texture. And we're gonna pass it the texture ID we just created and we actually set up. One thing is with width here. What's the problem? Have it set. No. We did need that. Interesting. Okay, there you go. At least that works now. And then gl.generate bitmaps, and this is also gonna help you with when you have like in a 3D game, mostly when you have a really high res, like for example grass image, and you're walking, it like kind of flickers around because it's just too high res. So it's just gonna help generate. It's gonna generate your bitmaps. It's just gonna be good. And then we just want to unbind our texture target, because we don't want to keep this texture in memory when we don't need to. That's the whole point. So 0 will unbind it, as we know when we were creating our meshes. And obviously we want to return our object now because we set it. Okay, so that's good. The next thing we want to do at this point is... Actually, we do want to make this public. My bad. Because we need to access through rendering. When we're rendering things, we need to be able to access our texture. Don't want to have to do this all the time, but for now it's going to be a pain. Eventually, what we're going to do is I'm going to make this so the sprite actually does the rendering, which is going to be good. Oh, it needs to be get private set as well. And what I mean by that is there's actually going to be a draw method in here instead of the mesh 2D. In fact, later the mesh 2D is just going to be the sprite, because we're never going to need to render anything else than a quad, and the quad itself is going to be transparent. I mean, it's not going to have any shading, but obviously that doesn't matter right now. Okay, well, I mean, the quad itself, no, the quad itself will not be transparent. Instead, what I think we'll do is the vertices will be transparent, and obviously if you send in a transparent image, that will be transparent. Anyways, now we're done for the most part, except the resource loading portion, which again, this is the really simple thing. So let's make a new class called resources. And we're going to use a little more generics here. The generics here are not going to be too complicated, but they will work with constraints. So this is first of all going to be a static class, which means we cannot have any non-static members in here. And then public static t, so it's gonna return whatever we return, and load t. String file path. And now we're gonna have some scripts. So where t, an I resource of t, obviously, and it has a what's it called? A empty parameterless constructor. So this is saying, obviously, t needs to inherit from I resource t, and it needs to have a parameterless constructor. If it does not fulfill those two, I guess, requirements, then it's not going to be accepted into the load function. It's kind of like a mini interface if you think about it. And over here, all we're going to say is, since it's a parameterless constructor, we can do new t dot load file path, because we can't take anything in here, right? And that's it. Eventually, I'm just going to put this to do check for file path validity. Yeah, I think that's how you spell it. And now let's just hook this up. So let's create a new texture. That's the first thing we're gonna do. And no, not a new texture, my bad. We're gonna create a new shader. Or a shader, my bad. Again, sprite, that's what we're gonna create. And then over here, we're just gonna initialize the sprite. I guess, yeah, that's fine. And I'm just going to use a... No, we're not going to initialize that. We're going to say resources.load. In fact, one thing you can do, I think this will work. You could technically... No, that won't work. I was going to say you could do it... Technically, you could do a private constructor, but then we can't construct it from the resources.load, and that's just going to get nasty, so there's no reason to. Anyways, yeah, so sprite is equal to resources.load, sprite... I'm going to pass in the file path here. And I'm just going to use resources slash, what do we want to call it? Let's call it, I'll make an images folder or something. Slash, fatcat.png. Okay? And then, to render this, we just need to say, before we start up our texture, or no, we can start up our texture before we draw our mesh. We're just going to say sprite.texture.bind. And we want to bind to the unit 0 because we have nothing else to bind to. And eventually, again, we'll make this so it keeps track of the bindings. And I mean, if you have more than 31 textures rendering, we'll see how we can handle that later on. But for now, it's not important. Okay, so now that we've done that, let's open up our resources folder in File Explorer. I'm going to make a new folder in here called images, as I said. And then I'm just going to copy the images here. So let me open and explore here. So I have this fat cat thing. I'm going to copy it into here. And I'm just going to make it like that to match our description on here. I guess it would have been easier to actually change it in Visual Studio in the code, but whatever. And look. We have an error. Parameter is not valid. And you may be wondering, why is it here? Well, this essentially is saying that our file path doesn't exist. Our file doesn't exist. And that makes sense, because if we take a look, our images is not included in the projects. So as soon as now we include the project, we have to just go into properties and make this to, copy if newer. Basically, that means it's going to copy our file to the output directory whenever we update the file. So we don't want to keep copying it every compile, especially when we have a ton of resources. There's no reason to do it. But obviously now you see we have a fat cat, and that's cool. But that's basically it. That's the full extent of creating and loading in sprites and whatever. Okay, sorry about that. I got a call. Anyways, yeah. So that's the full extent of doing sprites. So next video we're gonna try cleaning things up a bit, and we'll start doing lighting. 2D lighting is gonna be interesting. Anyways, guys, see you next time.